The next type of differential equations we're going to look at is when the differential equation is in the form dy dx equals g of y. Now g of y just means that it's in the form as a function of y rather than a function of x, which the previous one was. Okay, so if we've got dy dx equaling some function of y, what we do is we rearrange it first of all into this form. So we divide both sides by the function of y. Okay, so in doing so we end up on the left hand side 1 over g of y, whatever that function is, times dy dx equals 1, because g of y divided by g of y, of course, will be 1. And then that's the first step. Okay, second step is to integrate both sides with respect to x. Okay, so first of all, we've got dy dx equals y squared for this one. And we need to solve the differential equation for y. So in other words, we want to have y equals something or other. Okay, so first step, divide both sides by y squared. So we end up with 1 over y squared times dy dx equals 1. And now integrating both sides. With respect to x. Okay. The left hand side, we still have this 1 over y squared times dy dx, but of course we're integrating with respect to x, so we have dx. And now of course our dx's will cancel, and our left hand side will be, now I'll just change this, y to have negative 2 dy equals the integral of 1 dx. So the left hand side, what we're ending up doing here now is integrating this function of y with respect to y. So we'll end up with y to the negative 1 over negative 1 equals x plus c. Okay, we don't need to worry about a constant term on both sides. Let's just simplify it and have a 1 on one of the sides now. So now, of course, on the left-hand side we have negative 1 over y equals x plus c. And we want to solve for y, so we're going to make this y equals, and of course bringing the negative over here, negative 1 over x plus c. Of course, we really ought to specify that x cannot equal negative c, because we can't have division by 0. Okay, so that's our solution. So just going back over the method, we first of all want to bring our function of y over to the left-hand side, okay, rearranging in this form, and then integrating both sides with respect to x, so that in the end we're actually going to be integrating on this left side the function of y with respect to y, because our dx's cancel. And on the right hand side we work that through as well. So we're integrating both sides and then simplifying it, solving it for y. Okay, so let's look at another example. Okay, so we've got to find the solution to y dash equals square root of 1 minus y squared if y of 0 equals 1/2. Or in other words, y equals 1/2 when x equals 0. Alright, so y dash of course is dy dx. So our first step is to divide both sides by our function of y. So we've got on the left hand side now square root of 1 minus y squared times dy dx will equal 1 on the right hand side. Integrating both sides, we end up with 1 over square root of 1 minus y squared dy, because our dx's will cancel. Integrate both sides with respect to x. Okay, and on the right hand side we have 1 dx. integrating this, we can see and hopefully recognise this is arc sine. And arc sine y equals x plus c. And solving for y, we have y equals, okay, the inverse of arc sine is sine, okay, the inverse functions. So it's sine x plus c. Now that's our solution, except that we've got this extra bit of information, okay. If x equals 0, y equals 1/2. So 1/2 equals sine of 0 plus c, okay, or obviously we can get rid of the 0, so 1/2 is sine of c. So our solution for c, okay, we can just go with the first quadrant solution. There's no information given in terms of domain or anything. So sine of what equals 1/2? Well, we know that our first quadrant solution is pi on 6. So that means our solution to that differential equation is y equals sine x plus pi on 6. Okay, so that is our specific solution given that extra bit of information. Okay, so that then is our next, if you like, type of differential equation. And so we can practice those. Exercise 7E, question 1. And that's page 329. Of course, you can look at other questions in that one as well, but question 1 is specifically practicing solving those types of differential equations. Okay, so that's it for this video.